Okay, students. So, in the last class, we were in the syllabus of chemistry and also the oxidation and reduction part. So, because of some problems, today again I would like to tell you about the oxidation and reduction reactions along with total syllabus of chemistry and the marks allotment for each topic. Now, first we'll concentrate on the two important reactions called, one is oxidation, another one is reduction. One is oxidation and another one is reduction. What actually oxidation refers to? First definition, addition of oxygen or nascent oxygen. That is about addition of oxygen and nascent oxygen is nothing but oxidation. The question arises, what is actually the nascent oxygen? The word nascent refers to unstable, highly reactive, atomic species. Unstable, highly reactive, atomic species is nothing but nascent. If it is oxygen, it is nascent oxygen. If it is hydrogen, it is nascent hydrogen. And it is always indicated in the square brackets. It is always indicated in the square bracket. If I put oxygen, then it is called as nascent oxygen. Instead of that, if I put hydrogen, then it is called as nascent hydrogen. If it is chlorine, nascent chlorine it is. So that means they are unstable. They do not exist for longer time. Highly reactive, immediately they changes their states. That means they highly react with another substances. And they are atomic species, atomic state. So that is addition of oxygen or nascent oxygen is purely considered as oxidation. Like that, addition of hydrogen or nascent hydrogen is a reduction. Addition of hydrogen or nascent hydrogen is nothing but reduction. So, oxidation and reduction. This is the first definition. The second definition is this I will take out, okay? Removal of hydrogen from the reactant is also considered as oxidation. If we are removing hydrogen from the reacting species or reacting molecules, then it is nothing but oxidation. Like that, removal of oxygen is a reduction. If we remove oxygen from the reactants through any means, by any means, then it is considered as a reduction reaction. That is the second point. Third, loss of electrons. That means during the process, if electrons were removed, if electrons were lost, if electrons were comes out from the species, from the reacting species, then we call it as purely oxidation. Like that, gain of electrons is nothing but reduction. So, gain of electron, reduction, loss of electron, oxidation, removal of oxygen, reduction, removal of hydrogen, oxidation, addition of hydrogen or nascent hydrogen is reduction, addition of oxygen or nascent oxygen is oxidation. That is the first few definitions. Second point. Actually, in broader sense, if you add directly oxygen to the reaction, instead of calling oxidation, sometimes we call it as combustion reactions. So, addition of direct oxygen to the reaction, addition of O2, not O, O2 to the reaction is generally referred as combustion. Like that, addition of direct hydrogen to the reaction is called as hydrogenation. Hydrogenation. In broader sense, oxidation and reduction. But in some cases, if we add directly oxygen to the reaction, instead of calling oxidation, sometimes we may refer it as combustion. Like that, instead of reduction, if direct addition of hydrogen, if hydrogen is directly added, then instead of calling reduction, sometimes we may refer it as hydrogenation. So that is about the definition of oxidation and reduction. Okay, now I'll put one example here. CH3, CHO. This we call it as ethanol. Ethanol. To this, if I put hydrogen in presence of zinc amalgam with HCl, later on we will come to know what actually it is. Later on I will tell you about this. But at this junction we will see what actually the reaction. Then you are getting CH3, CH2, OH. Now, what type of reaction? Here addition of nascent hydrogen to the reaction is nothing but what? Reduction. Is nothing but what? Reduction. Now look at this example. CH3, CH2, OH plus O in presence of, I will take out this, alkaline KMnO4, that we call it as potassium permanganate, as you know already. Then you are getting CH3, COOH. You are getting acid, carboxylic acid plus water is coming out. Later on we will see balancing the equation. Here we want to concentrate on, we are targeting about the definitions. So therefore, here only one oxygen is there. But here after the reaction you are getting two oxygen atoms. That means we are indirectly adding oxygen to this. So that kind of reaction we call it as what? Oxidation. Because here oxygen is added to this. So that is oxidation and this is reduction. Now I will put one more example. Okay. Yes, 1 minute. Look at the second example. CH3, CH2, OH plus O. Again I will write the same reaction in explaining in another way. I am getting same product CH3COOH plus H2O. Now concentrate on this and concentrate on this product. What difference you are finding? Here, hydrogen, totally 3 plus 2, 5 plus 1. 6 hydrogen are there in the reactant, 3 plus 2 plus 1. But here 3 plus 1, only 4 hydrogen. That means removal of hydrogen is also considered as what? Oxidation. Is also considered as oxidation. So like that here, if I put CH3, COOH, acetic acid or carboxylic acid, in presence plus, I'll put H. In presence of the same zinc amalgam with HCl. Then here I will write the product part. CH3, CH2, OH plus H2O plus H2O. Now look at this. Here there are 2 oxygen atoms in the reacting molecule. Here only 1 oxygen is there in the reacting molecule. That means removal of oxygen. Removal of oxygen is also nothing but what? Reduction. Is nothing but what? Reduction. So that is removal of oxygen is reduction. Here there are 2 oxygen atoms. After the reaction, only 1 oxygen is left. That is reduction. Now we'll see the third definition. Third definition. Na give rise to Na plus electron. Now what the difference you are getting? Sodium after the reaction becomes sodium plus. That means here number of electrons will be 11, number of protons will be also 11. But after the reaction, 1 electron, that is only 10 electrons are there. That means 1 electron loss. That loss of electron is oxidation. Another example, you can take Z10 give rise to Z10 plus 2 electrons. Here zinc lost 2 electrons. Like that, if I write Cu2 plus 2 electron give rise to Cu. Here copper ions accepting, gaining electrons. So that is gain of electrons. So that is reduction. Reduction. So this is about the definitions of oxidation and reactions. Next point. Okay, next point. That is about oxidizing agent and reducing agent. Oxidizing agent and reducing agent. Okay, oxidizing agent and reducing agent. Now, oxidizing agent. You know already about LIC agent, the person who makes the LIC policies. The agent means the person who is responsible for LIC policies. Like that, the chemical which is responsible for doing oxidation reactions is called oxidizing agent. What the definition says? There are different definitions. Number 1, the one that provides nascent oxygen for the reaction or to the reaction, that is oxidizing agent. The agent that supplies, that provides, that gives oxygen for the reaction is oxidizing agent. Second, the one that removes hydrogen from the reacting species is also nothing but what? Oxidizing agent. Third, very important, the one that accepts electrons. The one that accepts electrons is oxidizing agent. The one that accepts the electrons is oxidizing agent. Like that, reducing agent, R stands for, I'll write complete, reducing agent. So reducing agent, the one that provides nascent hydrogen for the reaction. Any substance, if it supplies hydrogen, then it is called as reducing agent. Second, the one that removes oxygen from the reactant species. The agent that removes, that is responsible to take out the oxygen from the reacting species is a reducing agent. Then the one that here it is accepts, the one that is donates the electrons is reducing agent. So these are the different definitions for reducing agent and oxidizing agent. Nascent oxygen, the one that provides, hydrogen, the one that removes, and the one that accepts the electrons. The one that provides the hydrogen, the one that removes the oxygen, the one that donates the electron is nothing but reducing agent. Try to remember this. Reducing agent is always oxidized. Reducing agent is always oxidized, means it lost electrons. Donates the electron means automatically lost the electrons. So reducing agent is always oxidized, and oxidizing agent is always reduced. That is about the definition of oxidizing agent as well as reducing agents. Now, CH3, the same examples, CH3, CH2OH plus O in presence of alkaline KMnO4. That means the role played by KMnO4 is to provide oxygen for the reaction. So I can say here the product is CH3COOH, acetic acid. That means here this component we call it as oxidizing agent. Like that, potassium permanganate, potassium dichromate, sulfuric acid, nitric acid are all good oxidizing agents. Like that, if I take out this example and I will put this example, CH3 CHO plus H in presence of zinc amalgam with HCl, I am getting CH3 CH2 OH. That means this zinc amalgam with HCl provides the hydrogen, hence it is reducing agent. So therefore, what is reducing agent? It may be of any of these. And another important point, examples, you can take zinc amalgam with HCl, sodium with ethyl alcohol, sodium with ethyl alcohol, then zinc with HCl, nickel with hydrogen. Many examples you will find. Particularly transition metal with hydrogen, they always act as reducing agent, except few. So that is about the oxidizing agent and reducing agent. This is all about the oxidation, reduction, oxidizing agent, reducing agent. So this is total a bridge course to develop the first year concepts. Okay, now we'll switch on to the next part. Before going to the first year syllabus, let me give the whole syllabus, if possible, 10 marks. Okay, now okay students, actually the first year chemistry syllabus is divided into three parts. Physical chemistry, inorganic chemistry, and organic chemistry. These are the three branches. In organic chemistry, we will have three topics. We are having three topics. The first topic, some basic concepts or principles and techniques. Some basic concept, or you can say principles and techniques. It is actually a big topic. It covers almost what is organic chemistry and what are the methods by which we are detecting the elements, what are the methods by which we are estimating the elements, what are the mechanisms that can be used to explain organic reactions, or what are the factors that are responsible to undergo a chemical reaction, and some important isomerism concepts. Everything regarding whatever the basic requirement is there for to know about organic chemistry, that is explained in this topic. That's why it is a big topic. It includes several parts, including nomenclature, including theories to explain what actually organic chemistry is. All the details will be explained. And in the examination, it carries about 11 marks. In the examination, it covers 11 marks. Second topic, called hydrocarbons. You know already about hydrocarbons, compounds containing carbon and hydrogen. Here there are two types, aliphatic, aromatic, and one more is the heterocyclic. So details regarding what are aliphatic hydrocarbons, what are alkenes, what are alkynes, their properties, their preparations, everything. And along with aromatic hydrocarbons, their classification, their nomenclature, everything, their structures, everything, every word related to hydrocarbon is explained in this topic. It is also a big topic. So that topic also covers 10 marks. 10 marks. Now the last one, that is environmental chemistry. Environmental chemistry. So environmental chemistry, VIRON actually, okay? Now, environmental chemistry. So this environmental chemistry is about 3 months. Here you are supposed to study pollutions, different kind of pollutions and their effects into the nature or in the nature, and what are the remedial factors that we can to minimize that pollution is explained in this topic. So this is about the total organic chemistry. First one, some basic concepts or principles and also techniques of organic chemistry that carries 11 marks, is a big topic. Then comes hydrocarbons, both aliphatic and aromatic hydrocarbons were explained, and that carries about 10 marks. And the last one is environmental chemistry, that is about 3 marks. So this is the total organic chemistry prescribed for this year. Okay. Now comes inorganic chemistry. Okay. Inorganic chemistry. Okay. What is inorganic chemistry? You know already. Now we'll see. Inorganic chemistry is a big branch actually. It includes several topics. Now I will take out this first. Okay. Now, inorganic chemistry. Inorganic chemistry. Inorganic chemistry point of view. Inorganic chemistry point of view. Many topics are there. These topics I will take in the next class along with the marks allotment. Okay? So in the next class we will see about other branches of chemistry, what the syllabus prescribed, and immediately we will start with the topic of chemistry. Okay? Thank you.